Hi guys, I'm live. How you guys doing? Shirtless Guy here. I geeked out. I did some calculus and figured something out that, frankly, I probably haven't known since college. I like to nerd out a little bit with you guys. Math lesson time. Don't watch if you don't like it, but if you do, here it is. Okay. Hope this holds up here pretty good, and hope these pins right, because I barely can afford. I can't even afford pins, or I would have pins. It's not that I barely can. I can't. Okay. Now, a function. I'm going to find inverse function here. An inverse function is one such that if. All right, this one's out of ink. All right, very good. That means I'm down to my last pin, which if it runs out of ink, I have nada. If I have f of x and I have g of x, I'm going to define f of x and g of x as inverse functions. That means that if I take x and I go into f of x, and then I take that and go into g of x, I get x. They undo each other. You guys get that? And that's written as f is that what I do? No, not bar. That's derivative. F to the minus 1 of x equals g of x. In other words, you just put a negative 1 by the top. It doesn't mean 1 over. It doesn't mean to the negative 1 power. It means, in this case, inverse. So, and also, therefore, g of x, inversion of g of x equals f of x as well. Okay? Now, that's the definition of f of x and g of x so far. So now I'm going to write some more stuff here. Let's see. Functions undo each other. They're inverse functions. And let's say I have a graph. Let's see, how can I show this? Think. Let's see, let's show a graph like this. This pin barely writes. And I took the line y equals x. That's the line that goes right here, y equals x. And if you have inverse functions, I'll show an example in a minute. Like this, they happen to go reflexive around the x line. Oh shit, the sizes are about to topple over, and that's what I'm holding this up with. That's not a very smart idea, but I did it. That inverse functions are symmetrical about the line y equals x. It just works out that way. So imagine two functions, maybe make this one f of x, and make this one g of x. You can do the opposite too. In fact, I'm going to do both ways for my example. Okay? That's not a very good drawing, but the point is hopefully made. And it turns out that if I take x equals a and this is a, and it turns out that if this function is the inverse function of this function, then if I take the derivative let me think here. Okay, here's g, and let's say I have g, let's make a right. Well, I did a lousy job drawing that, but maybe make a right here. And let's say that the definition of the derivative is the delta y over the delta x instantaneous as the delta x approaches 0. So you could say derivative of g of x, derivative. This pin won't write, and I can't afford another one. g prime of x equals delta y over delta x, limit, I have to conserve my pen ink. I can't, I may not be able to do this video because I don't have any pens and these don't write. Oh shit. What am I gonna do here? Let's see if I have any other pens just laying around somewhere. I can afford pens, Jesus. What do you want from me? I think I have a pin right here. This one might work. If it does, miracle. Yeah, this one works. This one works. So let's just start the drawing over because this pin actually works. All right. So I have y, x and y. The line y equals x. I didn't even draw that right, but f of x. No. Wait, yeah. F of x equals x, or y equals x. It's a line right here. And then if I have a function that, let's say, it goes like this, and I got another one that goes like that. Okay, see that? And if I take the point A here, let's go, yeah, but point A here, and the derivative, and this is f, make this f of x, make this, no, let's switch it around. Let's make this g of x. Let's make this f of x. Yeah, so that's probably a little better. So you have points like this, and this is h, let's say, and this right here is f of x plus h minus f of x, and this is h. All right. So the derivative f prime of x equals the limit as h approaches 0 of f of x plus h. Jesus. I'm going to start over because I don't have room to write it here. Okay. F prime of x equals the limit h approaches 0 of f of x plus h minus f of x all over h. That's the definition of the derivative of f of x. As this delta h gets smaller, this delta y over delta x approaches the slope instantaneous of the line of the slope f of x, or y equals f of x. Yeah, f of x, right? And then that slope right there, because these lines are symmetrical, g of x and f of x are symmetrical about the line y equals x. It turns out that if I take, how do I do this? This h, this is a, so h equals a, wait. Yeah, that's a, h, okay. Let's say that's a. So, yeah, and that, so f, wait, okay, let's say that's a, okay, and x, yeah, okay. Now what I'm gonna do is, let's see what I can do here. Solve this thing. There's a symmetric, there's a point, there's a slope on this line g of x that is reflexive. In other words, this line has slope like this line's going to have slope like that. And they're both, and the slopes are inverted from each other. This one's rise is this one's run, and this one's run is this one's rise. So therefore, the two slopes, yeah, so that the derivative, this derivative here, the slope of this line, which is the derivative at that point, is 1 over the derivative of this point of this line at this point. I just have to show where that point is and relate it to this one. So let's do that. Let's do that work. So okay, if I have this one, okay, this is f of a. Let's say this is f of a. H is this little line segment right here. This is a. And what I'm going to do is f of a, f of g of x. Okay. A. Okay, let's say this point here, where this line tangent is going to be, let's say that is, okay, that would be this, and g of x, you have, let's say this point is a. I keep making a different all the time, but hey, okay. Let's say this is a right here. And I have a slope for g of x. So the slope of g of x is similar. Limit as h approaches 0 of g of x plus a minus g of a all over h. And then I have this one over here. I have this, and these two these two slopes are inverted. That means one is 1 over the other. How do I go about showing that? Okay, let's do it like this. If this is A right here, then this is B. Let's make that B. Okay. And then this slope here is A plus H, and this is H, and this is G of wait. Oh yeah, C. A, B, G of let me think. Okay, so I have this here. Let's see that. Oh, I'm getting it here. Okay, this is going to be symmetric. These are reflexive. Yeah. So watch this. If this is A and this is B, this is B here and this is A, then it can be shown that if I go B here on this line right here, and I go up A this far, then that's the symmetrical point. It just works out that way. If these functions are reflexive symmetrical about the line y equals x. Dun is dun, they're inverted. So if this is B, this is A, and this point is here, It's the corresponding point is B and A. Reverse though, B A A B. It's because they're inverse functions. It's kind of like they undo each other, or like there's that symmetry. Like if F F of A, no, if G of A equals B, like I'm showing, G of A equals B, and then I have F of B equals A. This is F of B, which is equal to A, and G of A is equal to B. How does that work for reflection, for inversion? Well, if I have, if I say, if I, well, it just is. It's just symmetric. It's because it's symmetrical about the line y equals x. It means if you flip them this way around this line, they would reverse that way. You just see it geometrically. B A B. They switch. Okay. And so this slope here and this slope here are going to be inverted slopes, because one of them is up a certain amount here, and one is, let's say, wait, let's do that better. One slants more up from that line, one slants more down. See, the line goes through like that. This one has a greater slope here than this, and the slopes are inverted at that point, at these 2 points. Okay, so let's see what that means. I'm just going with the flow here. I understand this is a matter of explaining it. Okay, so all right, let's do this. If I have this derivative here is going to be the limit as of x plus h minus f of x over h as h approaches 0. Yeah. And h is this little piece right here. Let's see what we can do. Yeah, this h is this little piece, and the derivative, is the limit as h approaches 0 of f of x plus h minus f of x, which is this, divided by h, which is that. Okay, fair enough. And if these slopes are inverted one from another, that means if this slope were 5/4, this one would be 4/5. They're inverted. Reciprocal. That's what I'm looking for. All right. Now, how do I figure this? I'm going to do something here. Okay, so what I can show, that was just an example, doesn't need to be shown forever. If I have this f, this is f of b is a. F of b is a, but f of a is b and g in the g of x. So if I take a b right here, let's do this. I didn't mean to make that mark. If I take a b here, do you see that b? Let's check this out. This b here is equal to g of a. You guys see that? The function g of x at x equals a is b. So therefore b equals g of a. See that? Let that sink in. So this b here is g of a. So this b is g of a. And this is g of a. And this A here is, this A is f of B. So A equals f of B. A equals, no, wait, that's not. Yeah, f of B equals A. That's right. And G of A equals B. Okay, there we have it. These two equations work. So far, so good. So, what can I say? If this derivative here, which is the derivative of f of x, f prime of x, let's say, let's write it down here. Let's do some work down here. Erase this a little bit. F prime of x prime of x okay, f prime of x equals is the slope here, which is the inverse slope of this one. Therefore, inverse means 1 over. So that means that the derivative of f of x, right here, yeah, I get it. Derivative of f of x is, I get it. If this is x, this is y. If this is y, this is x. See that? So if f of x is y here, then g of y, equals b. There. F of x, f prime of x is this slope. And if, okay, and I don't need that equals there. That's just slope. I just wrote the slope right here. And it's f of x. This is f prime of x. And oh yeah, so f prime of b. Wait, b. All right, f prime of x. Oh, I see. So if this is b, this is a, this is a, this is b. Got it. So f prime of x is this slope. All right, that's that slope. But this slope is the inversion of it. But this slope is g of this, g of a. Okay, g of a, but that's g of y, because this is y, because this is y. So g of y, wait, g of y equals b. Yeah, g of, well, that's, wait, g of y, that's g of a equals b, actually. G of a equals b. Okay, that's what I meant to say there. G of a equals b. G of a equals b. All right. Now, what do I do? B is g of a. And this is f of x. So I want f prime of b. Yeah, f prime at b. That's what I want. F prime at b. at B. Yeah, f prime of B is this slope, which is, okay. But B is G of A. See that? Now, what I do is I say that these two are inversions of each other. So I'm going to use the space up here, and let's make okay, let's make this f prime of x. F prime of x is this slope. Right now x is b, but that's just one point. F of x equals this slope. F prime of x equals this slope. But this x is b, and b here, this b is g of y. Because y is this much. And yeah, g f prime of x, this, and yeah, this point, this slope is the inversion of it. So if I have f of x, prime of x is this. Okay, but okay, let's scratch that. This x here is this much, which is this much, this here, yeah, this much is that, and that is would be g prime of A, because g prime of A, no, I get it. You want this, you want the slope of, at this point, is f of x. But this x is b. So x equals b in this case. But b equals g of b equals g of a. That's how it goes. Yeah. G of a equals b. And this x equals b, right? Get that? But b is equal to g of a. So if I want f prime of x, I want f prime of b, but b is equal to g of a. So I have f prime of b equals f prime of g of a. And I can barely have room to write this. That's just so stupid. I'm going to start over because I don't have the damn room. F prime of b equals, there's some space here, f prime of g of a. Okay, so this is this f prime of x, but x equals b, but b equals g of a. So f prime of b equals, yeah, f prime of b here, which is g of a. Okay. F prime of g of a. Right. Okay, so far so good. So this much we have right here, f prime of b equals f prime of g of a, because b is equal to g of a. But f prime of g of a is this slope. In the other example, I said it was 4/5, slightly less than 1. The rise over run is 4/3. So the rise over run is the rise is less than the run, so it's less slope than 1. But that's equal to this. That's the inverse of this slope here, which is greater than 1 because it's 5/4, and that is the slope here, which is G prime of A. I can't write. G prime of A. That's this slope right here. And that's what I said is 4/5. Get that? But these are inverted. For this is 1 over that, and that's 1 over this. So that means that I can write. I'm going to do something. I'm going to just erase this because I need the room. I hope you guys got that. LOL. Not that that's funny, but okay. So I have these are inverted. F prime of G of A is inverted from this. All right. That means that F prime of G of A. Dude, I take some penmanship lessons. F prime of G of A equals 1 over G prime of A. Yeah. Or let's even write it, which I can also write it as G prime of A equal, now I'm running out of room again. G prime of A equals 1 over F prime of G, and I can't write again. 1 over F prime of G of A. Barely read that myself. That's better. So G prime of A equals 1 over F prime of G of A. And that is a formula that's very important in calculus. It's one I worked out tonight. But I'm not going to leave you hanging because that kind of leaves you going, maybe, huh? But I think you get the concept, hopefully. But let's do an example because that'll bring it home, I think, because it did for me when I did it, when I learned it tonight. So there's the equation for us. Prime of that. Okay, and that's an F, blah, blah, blah. Okay, let's do an example, and then we're done. And I can go home. It's a line from Myself Better Than You. What's it called? By Nirvana. On a plane. Okay, let's try this out. I said G and F are inverse functions, right? So let's say F of X equals log X. And let's say G of X equals e to the X. All right, that's cool. Are those inverted functions? Well, an inverted function is such that if you take X into F of X and then go to G of X, you get X again. And we're going to test that. Don't forget this formula. In fact, let's write it down here and then erase it up there. G prime of A equals 1 over F prime of G of A. Let's erase this because I didn't need to be that big right now. All right, 1 over. Okay, there we go. Is that true? Well, if I take X and go to log F of X is log X, then I go to G of X is e to the X. So G of X is e to the X, and if X is log X, then G of X then equals e to the log X. E to the log X is equal to X because e exponential natural logarithm and e exponent function are inverse functions. The e to the log x is x, and also log e to the x equals x, but e to the log x is also x, because e, the exponential function in the natural logarithm base, which is the logarithm base e, are inverse function, are inverse functions. So that is true, they are. So that means that that means we can define f of x as log x and g of x equals e to the x. That's all that means. We can define that because we know now that logarithm x and e to the x are inverse functions. How does that relate to this formula down here? Let's see. Let's do this. We know that derivative d dx of e to the x equals e to the x. D dx logarithm x equals 1 over x. That's just formulas we know in calculus. Check it out if you want. They're true. So what do? G prime of a. All right, G prime of a. I'm going to write g of x is e to the x. So let's g prime of x is g prime of x is g of x is e to the x. So g prime of x equals e to the x, because g of x is e to the x and d e to the x dx is e to the x. So g prime of x is e to the x, because the derivative of e to the x is e to the x. So I have this. Very important that we know this. Okay. So far we have g prime of x equals e to the x on this example. What's f prime of g of a, or g of x, let's say? Well, f of x equals log x. F of x. So now I'm going to need room up here. F of x equals log x. F of x equals log x. I just repeated that. But it turns out that f prime, because the derivative of log x is 1 over x. So f prime of x equals, now I'm running out of room again. F prime of x equals 1 over x. That's just the formula. That looks funny right there. F prime of x equals 1 over x, because f of x is logarithm of x, and the derivative of logarithm of x is 1 over x, so f prime of x is 1 over x. See that? So f prime of x equals 1 over x, but you want f prime of g of x. What's g of x? E to the x. So what's if you want f prime of g of x, f prime of g of x, and I'm just scribbling, equals f prime of e to the x, because g to the x equals e to the x. Yes, f prime of g of x, e to the x. F is logarithm of x. So f prime of e to the x is what? F prime of e to the x. Since you want f prime of g of x and g of x is e to the x, you want f prime of e to the x. What is f prime of x is, no, f prime, yes, f prime, that's, yes, f is log x, yes. So if f of x is log x, f prime is 1 over x. Got it. F prime of x is 1 over x. So f prime of e to the x equals 1 over e to the x. Okay? So if f prime of e to the, and since And since g of x equals e to the x, f prime of e to the x, which is 1 over e to the x, and e to the x is g of x, because g of x is e to the x. Basically, that means that this f prime of e to the x is f prime of g of x, because g of x is e to the x. See that? E to the x is g of x. So f prime of g of x is 1 over e to the x. This is important. But g prime of x equals e to the x. So what did that show us? And we want to verify this equation. G prime, here we go. Let's do this. And what I'm going to do, I'm going to do a bold move. I almost caught it with that. This is one of the, this is a mask I'm using for a wipe. These masks we used to wear for COVID. Okay. So here we go. We got this and this, and we're going to verify this. We want to verify that g prime of a equals 1 over f prime g of a. If g prime of x is e to the x, then you have g prime of x equals e to the x. Is that equal to 1 over f prime of e to the x? Because f prime e to the x is f prime g of x is 1 over f prime of g of x, which is this, is 1 over e to the x. So f prime of e to the x, which e to the x is g prime of x equals e to the x. We had up here that g prime of x is e to the x. So that's this. And f prime g of x, f prime g of x is 1 over e to the x. So let's do it like this. F prime of, let's do this again. F prime g of x, 1 over e to the x. G to the x, g prime of x equals e to the x. And f prime, okay, here I go. So let's do this again. G prime of x is e to the x. That's this right here. G prime of x is e to the x. But that's supposed to be equal to 1 over f prime g of x. But f prime g of x is 1 over e to the x. It says so right here. F prime g of x is 1 over e to the x. That's this. G prime of x equals e to the x. So that's here. And that's this side. G prime of x equals e to the x. This is 1 over equals 1 over f prime g of x, which is 1 over e to the x. So here's our here's our thing. But is this equal to that? Well, almost done. Erase all that. We got it. I think we got that. Are those two things equal? Well, it turns out that they are, because e to the x is 1 over e, 1 over 1 over e to the x is e to the x. Because the inversion of the inversion of e to the x is e to the x. The 1 over flips it and becomes e to the x. So yes, e to the x is e to the x. So we proved our theory. We proved it that all in all, it's just another brick in the wall. LOL. G prime of x is e to the x. So G prime of x is e to the x, but that's equal to 1 over e to the x, which is f prime of g of x. And that is our theorem, our theory for today. I don't need this line through here. That the derivative of g of x at that point here is 1 over, the derivative of this point, g of x is equal to 1 over f prime g of x. Yes. Oh, I get it now. No, this was g of x up here. G of x up here, this g of x was this slope up here, is equal to 1 over this derivative here, which was f prime of g of x, which is right. This is f prime of g of x. Wait. Make sure I got that right. 1 over, this is it, g prime of x, 1 over f prime of g of x. Because that was what you wanted there. I think so. I think that was our theorem, I think. Prime of g of x. X. What was f? Here, t here. Got it. That's true. Okay, got it. That's right. Because you take this g was up here, and take the derivative at x. The f was down here. This is the derivative of this, which was this, and then that is first derivative 1 over g. Yeah, that's right. Because this was your A. This was your, you got the lines here. Remember this? This line here had an A. I had an X that went up right here, long like this, and then Y up here, and then you took the derivative. Yeah, at that point, and that's inverted of the derivative up here, which is the derivative of this at this X. G of x. Yeah, because g of x is up here is this much. And that is equal to this x, which is f prime of x, g of, got it. Okay, that's your formula. It's kind of tricky, but it just means that if you have two functions, g of x and f of x are inverse functions so that they're symmetrical about the line y equals x. They go opposite directions. And if you go this far in this one, that would be this far here. If this is f of x, make this x equal to this value up here, which is this is f, this is your f of x here. You want the x to go right here, and that x is equal to, wait, I do that. Wait, I think I did that right. Let's make sure. I got this, and I go f, whatever, f prime of g of x, I think. Yeah, that's right. I'll explain it again. The derivative of this f at g of x, which is this point up here, that's this point here. So you're taking f the derivative of f prime of g of x is this slope, and that x which you want to take is this g of x, and that g of x, that g of x is because this is g prime of x. So this g prime is a g prime of a little x here. And then that g prime is up here. That's this slope, is inverted of, that's f prime of g. Yeah, I got it. That's right. This slope here, the lower line, at the value of this function here, which is up here, right here, is inverted or 1 over this slope, which is g prime. This slope is g prime of x. So what do I have here? This was f prime g of x. This is g of x. I'm going to go x. Yeah, prime. Okay, you got x. Yeah, because this longer point is prime g. Okay, let's check it out. G prime, this is equal to 1 over. Figure this out. G prime of x equals e to the x. So that's this. 1 over that. This f prime of g of x. F prime of g of x. Let's see. Prime. G prime of x. Well, this is x. Okay, let's say this is x. G prime of x is this. And you want to take, this is x. G prime of x. This is x. I think it's got to be g prime. I think that's the answer. Has to be, because g prime of x. Wait, g prime of x. That doesn't make sense. No, that can't be. Wait, that's the x. Wait, this is x f prime of. No, that doesn't need to be there. That's not true. It's like that. Yeah. That line there's 1 over. So the derivative of g prime of x is 1 over derivative of this, which is here prime of an x, which is g. Yeah, that's correct. I got it now. Since I just took so long, let's explain this again. So let's write this, this out here, and I'll explain what I just went through once again. So let's make sure we're good. So you have the line here, and you have this one going up like this, and this one going like this. This is the line that separates them. The y equals, they're reflected across this line. If I go f prime, if I take this derivative here, I would go, I'm supposed to go this far, and then that would make as much as this is up here. But if this is this much, if this up here is this, then this, if this little bit is x, then this little bit here is x. Okay, and so that little bit is x, this little bit is x here, but this little bit up here, this big bit, is g of x. It's bigger. This little x is little. This little x is little, but this big here is also g of x. Get that? If this is x, if this little bit is x, this much is g of x, and this much is g of x, and this much is x. So if the slope g prime of x is this big one, which is this big one is g of x, and the little one is x. Okay, that's g prime of x, g of x over x, like this, essentially. And then this slope here, f, this is the inverted slope, that g prime of x. So what I mean is, this is x. This is g of x. So if I take g prime of x, that is this slope. So it's this slope up here. That's g prime of x. Got that? This is 1 over this slope, which is f prime of the big line, which is g of x. Yeah, so it works. So g prime of x equals 1 over f prime g of x. That's how it goes. Because this is the g of x line up here. This is the f of x line down here. This line is the f of x, and the slope at f of x, but x is equal to g of x. So that's why this is here. So the slope here at the point g of x, which is this longer point, is the inversion of the slope of g at this little point x. So that's your equation. So I took this long to figure that out, but it's true. And I don't have a book here, and I'm not verifying it. I just know that that's the way it goes. So there's that equation in calculus. It's if g of x and is, let's say, e to the x, and f of x is logarithm of x, which we just did that one. Yeah, we did, but let's change it up. Let's make the reverse and see if that works then too. Okay, let's do that. Let's make the f of x equal to e to the x, and the g of x equal logarithm of x. Let's do that. That would be the reverse, because this time the f of x would be the line up here, and the g of x would be the line down here, right? And not the line with the curve. Let's see if that works too, and then we'll really be home. So this is the equation we're trying to verify. So g prime of x is is g prime of x, it is g prime of x equals 1 over x, because g of x equals logarithm of x. Just more space here. G prime of x equals 1 over x. We know that because g prime of x equals logarithm of x. A g of x equals logarithm of x. G prime of x is 1 over x. But f prime of x equals e to the x. But you want f prime of g of x, but g of x is logarithm of x. So f prime of x equals e to logarithm of x. I can write, which is equal to x. So f prime of g of x is equal to x. See that? But g prime of x is equal to 1 over x. So if f prime of g of x, because here x is equal to logarithm of x, g of x is logarithm of x. So when I said I made this f prime of x is f prime of g of x, because g of x is logarithm of x. So f prime of g of x is f prime of logarithm of x, but f prime of logarithm of x is 1 over x. Wait, f prime of g of x, g of x is logarithm of x. So f prime of logarithm of x is f prime of g of x. And f prime of g of x is f prime of logarithm of x. And f prime logarithm of x is 1 over x. So this much here is a second here. G prime of x, g of x is logarithm of x, so g prime of x is 1 over x. But how about the f prime? I wrote that too big down there because I'm not having enough room to write it up here, but f prime of x, f of x is e to the x, so f prime of x equals e to the x, but f prime of g of x is f prime of logarithm of x, which is e to the logarithm of x, which is x. See that? So that means that this much is x, because this is f prime of g of x, but g of x is logarithm of x, but f prime of logarithm of x is e to the x, but x is g to the x, so you have f prime is e to the logarithm of x, which is x. They cancel each other out, and therefore this much is x. See that? So this much is x. This much is 1 over x. Now, but final verification, then we're done. We did it. That we know, we see that 1 over x equals 1 over x. Because this is this, this is this, this one is this. Wait, not that. Look at this, if you want. This is 1 over x. This is, the other thing is x. But they were supposed to be inversions. So 1 over x equals 1 over x. That's it. See, this whole big thing was x. So you had 1 over that, was 1 over x. This is 1 over x, so you had 1 over x, and 1 over x is equal to x. So it solves it. Yeah, we did it. Because 1 over x is the inversion of x, because 1 over x is 1 over x, and this big thing was x, this whole thing was 1 over x, and that 1 over x is equal to 1 over x. So our equation worked. I'll write it out one more time. We want to get that straight, but hey, whatever. So you have g of prime of x equals 1 over f prime of g of x. If g of x equals f negative 1 of x, meaning that g of x and f of x are inverse functions. And if that's true, then this is true. And inverse functions means that x going into g of x going into f of x equals or goes into becomes x. Is that true of exponents and logarithms? Well, have x. If g is logarithm of x, then you have logarithm of x. If f is e to the x, you have e to the logarithm of x, and e to the logarithm of x equals x. And so x is the beginning at the end. Therefore, exponential functions and natural logarithm exponential functions and natural logarithm functions are inverse functions, and that makes this true for them. Love you guys. Peace, love, and rock and roll.